Thank you for coming. One question that a number of you have been asking me this week is, why is Salesforce here at a telecom conference? After all, we're an enterprise company and we're focused on software as a service as opposed to telecom workloads. But I've been involved with the SDN and NFV journey since 2011, 2012. And I see a lot of parallels between what we've all been building through SDN and NFV over the last close to a decade, and what we are doing at Salesforce, particularly in the public cloud. So I'm going to talk today about some of the automation work that we're doing, specifically around network security. And my clicker doesn't seem to be working. There we go. Try this one. So if you talk to people at Salesforce, we will all tell you that trust is our #1 value. And your data is important to us, and we're taking great stride to always make sure that it's protected. Also, just like many of you, the pace of our business is accelerating, and we need to meet that pace with increased velocity. So we are building enhanced cloud-native security automation that improves our operations posture in our multi-substrate environment. And this gives us parity between our first-party data centers that we operate all over the world, and also public cloud environments through different providers, while increasing our velocity as we go along. And by approaching our operations holistically, we can enable enhanced automation tools, and for us, this increases our responsiveness, reduces our errors, and allows us to rapidly adapt to the dynamic environments that we see in the public cloud space.
You need the other clicker.
Let's see if this one works. There we go. So let's go over the public cloud network security basics. If you look at the cloud security architecture documents, first they'll tell you to start with a virtual private cloud, a VPC. Inside of that, you might start with a layer of load balancers, and then a web tier, followed by an application tier, maybe a database tier with buckets for your storage. You apply security groups to each one of those tiers, and you have perhaps a direct connect with potentially encryption back to a corporate data center. Pretty simple, right? But what about at scale? At Salesforce, we want significantly more isolation between all of our different services. And so we use multiple different VPCs. And we have tight security in between each one of the interconnections. And what about when you want to bring in automation, particularly in a multi-cloud environment? Now it starts to get much more complicated. We don't just want to go through the cloud provider console. We want to do the automation methodologically. So we use an infrastructure as code approach to help automate our deployment. We have a CI/CD pipeline, and then common development and deployment tools. For example, you could use Terraform or Spinnaker in your environment. And model your deployment with a declarative model, ideally a provider-agnostic model if you want the flexibility of working with multiple partners. So here's an example. This is fairly common in the industry. It's nothing unique to Salesforce, that you have the continuous integration with plan, code, build, test, and bake, and then continuous deployment with deploy, operate, and monitor. And this is really good for delivering new services into the environment. Well, what about day 2? What happens when this has been already pushed out into the environment? I take a little concern with the operate box in the continuous deployment piece because I think that's a little bit oversimplified. And when we talk about day 2, we can be more robust and do a better job. So some of the challenges as we build out our system are very similar to what many of you face. We designed it, break this down into both the design time and the runtime. And for design time, we want to ensure that we have a common security posture across all of our different areas by standardizing and normalizing the change sets. Second, we want to allow self-service and rapidly deploy changes while ensuring quality. So what happens if you allow your developers to self-service their own security policy? In many cases, they're not the security engineers, and so we want to make sure that security has a chance to validate that all the changes go in, meet the approved patterns, and they don't generate any anti-patterns. But we also want to reduce manual effort for both the security team and for the developers. So we spend time focusing on verifying all of our changes before they take effect, making sure that they meet the approved levels of security and they do not hit any anti-patterns. Once our changes are deployed, we have runtime considerations. First, we want to provide visibility to our operations staff with a single pane of glass so that if there is ever an issue or an attack, that they have a quick way of going in there and troubleshooting the idea so that we can respond appropriately. Second is integration. This is through multiple different services and multiple different security controls that we want to harmonize our information to isolate issues and then also to make it easier to troubleshoot. If there is a concern, we have to get in there. We don't want to have 5 different teams on a conference call to figure out which component needs to be adjusted. Also, predictive analytics. We want to identify potential problems before they occur, or if we are being attacked, to be able to quickly diagnose what the issue is so that we can respond to it. And then auditing, very similar to verification. We want to make sure that all of the security controls are set up as they're supposed to be, and also to detect anomalies and potentially vulnerabilities in our environment. Within our organization, we call this DevNetSecOps. And this is always the problem when the engineers come up with the naming. Our DevNetSecOps principles, first, are that we want to enhance the security posture through consistent and machine-readable policies. And this also helps us to build intake tools, which dramatically speed up deployment of any new policies. Second, we want to reduce human effort wherever possible. that all the changes to the environment go through our automation pipelines. Sometimes we need to have exceptions for break fix, but we want to minimize that as much as possible. Also, we want to execute our changes rapidly and also validate them before they enter production. So nothing is just going to blindly enter the environment, that it goes through multiple levels of checks. Also, we want to make sure we have good documentation on the current state of the environment. We can store the runtime state in key value stores or DDI and IPAM solutions for managing IP addresses. We also use tools such as Git to maintain the configured and the committed state. And we want to ensure that the run state is eventually consistent with the design state. In many cases, we have change windows, and so we'll only deploy the changes during those windows. But we do want to make sure that we have a well-defined pipeline and well-defined checks to make sure that what is in the running environment is consistent with what's in our configured environment. And then we want to follow this up with auditing and testing to confirm the current state of the environment. And here is where I think there are a lot of similarities with what many of you are building, both in your own infrastructures and then in the open source projects. And this is closed loop automation. So to the generic pipeline we talked about a few minutes ago, we add a number of different steps. One is validation, so that all configurations are checked pre-deployment against the approved policies and our defined standards. Second is that we want to augment the monitoring capabilities. So we start with the cloud provider specific tools which are necessary to check the state of the infrastructure. We also have application-specific tools and other tools that we have in our first-party environments that we bring forward in public cloud as well. And on top of that, we need some additional tools to check the state of the public cloud substrate under us. For example, if one of the providers changes their API server IP addresses, we need to react accordingly and adjust our security posture to allow access to the new addresses. Next is analytics and correlation tools, so that if there is a discrepancy or an issue in our environment, we can quickly zero in on that and quickly address it. And then policy-based controls that determine the appropriate action. In some cases, we will auto-remediate. In others, we would want to send it to an ops engineer or send it back to the developers to make updates within the product. Part of this is also to be able to respond to dynamic changes within the environment. If we would see, for example, a security attack, we can use the same closed loop. Let's say there was a vulnerability that was released in some software package. We can use this type of approach to notify the developers to update the components, and then in the meantime, put in mitigation techniques through the closed loop automation to essentially provide additional virtual mitigation while we push through the patching. And then we tie this together with auditing to compare the desired state with the runtime environment. I know many of you are building and using similar techniques. This is a lighter weight version, but I think there's a lot of crossover between our respective companies. And some of the considerations as we build out our systems is that the native public cloud capabilities are necessary, but they're not sufficient. They're absolutely required for setting up and monitoring the infrastructure, but we've found that we need to augment this with some of our own tools to make it more specific to our environment. Second, we bring in a lot of commercial offerings to help us build out our platform. We work closely with our partners in this, and they can help, but in some cases they're less mature in the public cloud space than in the private data centers. So to address those challenges, we're augmenting and integrating using custom tools. We will bring in open source where it's appropriate, also developing serverless or Lambda scripts to do some of the monitoring and remediation, and then also additional in-house tools. Also, we focus very closely on the data model and on the schema so that all of these changes are repeatable and easy to automate. And then start small, build quickly, and iterate. I'm a big fan of the lean approach, and we've seen within Salesforce that we can drive value in our systems very quickly using this general approach. So key takeaways. First is that you can enhance security, velocity, and quality through automation. Second, I think public cloud is making many different industries, particularly in the technology space, come together. Specifically, it's bringing together the enterprise and the telco architectures. And at conferences like this, I think there's a great opportunity to work between the enterprise companies and the telcos to work together to share experiences and best practices. And I think both sides will benefit from the interaction. Thank you.